Hello everybody, welcome back. We'll do Pas Pascal's triangle this time. Okay. Um, think I should bring this whiteboard closer. Oh boy. Okay. We're gonna write quite a lot, so we should bring this whiteboard as close as possible. Okay. It's Pascal's triangle is way to this kind of algorithmic way. What's an algorithm? Well, you have procedure, sequential procedure, ordered steps. That's what algorithm is. Okay, you have several steps, and you repeat it at the same time, same fashion. That's what algorithm is. Okay, a set of ordered set of steps, ordered set of actions. Okay, and that's what algorithm is. So Pascal's triangle is way to find binomial coefficient. Okay, binomial. What is binomial coefficient? Let's say you have a plus b times a plus b times a plus b. Okay. Now, okay. How many ways are there? So multiply a plus b multiplied by 3 times. Okay. How many ways there are to pick uh, okay, let's take a step back. A plus b times a plus b is equal to, we'll use the distributive law, a squared plus ab plus ba plus b squared, right? Is equal to a squared plus 2ab plus b squared. Now, what you gotta notice is this, okay? How many ways are there? So there are two a's, okay? To pick two a's. There's only one way, right? And equally, how many ways there are to pick 0 b's? Here we are picking two a's and 0 b's, right? So it's equal to, and ordering doesn't matter. You pick A and then A, or A and then A. Ordering doesn't matter, okay? So it's 2c 2, which is 1, right? A squared plus now how many ways there are to pick 1a and then 1b? There are two ways, right? So there are two ways, right? Out of two, we are picking 1a. Okay? Either we pick this A or this A. So there are two ways. So two A's out of two, we are picking 1A. Out of two A's, we are picking 1A. Okay? There are two ways to do it. Either we pick the first way or second way. Okay? So, and once you pick 1A, the next one is determined because you're picking B, right? If you pick this A just once, you're picking the other B, okay? So, that's why we need to consider only A, okay? Now, how many ways to pick two B's out of two B's? One, right? Or we are picking 0 A's, okay? When we pick two B's. 2c0 b squared. Okay, and they're symmetric. Okay, so 2c2 and 2c0, they are the same. All right. So that's the intuition. Okay, so it's combination. Okay. It can be very confusing because it's as if we are doing the combination, allowing the repetition, but it's not. Why? Because this A and this A, they are two different things. Okay, they look the same, but we consider it as two different things when it comes to this combinatorics. Okay. Yeah, I understand it could be confusing. Okay, and but it's just what it is. All right. Yeah. Probably I'm not being a very good teacher. So please, if you're not quite getting this, please look up binomial coefficient. Okay, then they will teach you on in the internet a lot better than I can. Okay, so and we're gonna okay. Let's draw the Pascal's triangle. Okay. It's like this. All right. You one on the edge of this triangle. You draw one, and you have two upstairs diagonal bosses. You add them up, okay? And you have one, then three, 1 plus 2, 2 plus 1, 3, and then 1. So that's Pascal's triangle. What is this? A plus b. 2c. I think it's this 1c0, 1c1, 0c0. Now you have 2c0, 2c1, then 2c2. Yeah, so that's how it is. Okay. And you have 2c0, 3c0, 3c1, 3c2, 3c3. Okay. What is it? 3c. Okay. So that's Pascal triangle. I'm sorry, I'm not quite writing clearly, but and probably it's fairly easy to prove. It's this equality, okay, in NCR plus NCR plus 1 is equal to N plus 1 C R plus 1. Okay, you are adding these two. NCR plus NCR plus 1 is equal to N plus 1 R plus 1. Okay, so it's this equality. Okay. Probably it's very easy to prove in terms of this factorial. Okay, why? Because let's see. What is NCR? NPR over N minus R factorial plus you have NPR plus 1 over N minus R minus 1 factorial. Okay, so that's the left hand side. Left hand side is that. Right hand side is very well known mathematical proof technique. Okay, you explain what left side is, you kind of expand what left side, you write out then what right hand side is. right hand side is equal to n, you subtract this 2, right? N minus r factorial, it goes downstairs, and then you have n plus 1 p r plus 1. Okay? Okay. And this guy is equal to, well, we multiply by n minus r, or here n minus r there, okay? This guy is equal to, we don't need this guy anymore because we wrote it out, so I'm sorry it's kind of boring now because I just rolled out of my bed, totally overslept, so I'm not really 100% now. And what is NPR? Wait a minute, did I do this right? NCR. Oh, I think I made a mistake. Okay, NCR is equal to it's not r n minus r. Okay, I'm sorry, I made a mistake. Is equal to, what is it? N minus r factorial n factorial, something like that. Yeah, okay. All right, if that's the case, the original equation was oh boy, oversleeping. And CR plus N CR plus 1 is equal to N plus CR plus N plus 1 CR plus 1. So that was the original equation. Okay. So NR N minus R factorial R factorial, I'm correcting the equation, okay, over n factorial, okay, plus r plus 1, yeah, n minus 1 r minus 1 times, and then you have r plus 1 factorial over n factorial, okay, and right hand side is okay, this is the right hand side. Our goal is to make these two guys look like this, okay, to make these two guys eventually look like that, okay, so that's our goal. So looks like we need to multiply by okay, so this guy is equal to really running out of space. This guy is equal to make left hand side look like right hand side, we need to multiply r plus 1, okay, then you have n minus r factorial r plus 1 factorial, so let's go downstairs, you have n factorial times r plus 1, right, we are multiplying by r plus 1, upstairs, downstairs. Here we multiply by n minus r, okay? N minus r. Okay, then you have n minus r factorial, okay? Which is equal to you you know, in mathematics we have this distribution, you can expand it, or you can factor it, right? Factor it. So you have n factorial is common factor, so you factor it out and you add them too. Add both of them. Is equal to n plus 1, r minus r cancels. So yeah, we got it. Okay. So yeah, it's fairly simple algebraic manipulation. How to prove this? Okay. So that's Pascal's triangle, and in terms of the combination, you have n. Just for example, you have 3h2. Okay, it's combination. We are picking 2, okay, but we are allowing repetition. All right, so that's what we did. Okay. For example, you have a king, queen, and jack. Okay. So we are allowed. We're picking out of 3. We're picking 2 cards. We allow repetition. Okay. So you have 3 cards. You put 1, and you write down what the first pick was, and you put it back, so that you can allow the repetition. Okay. So how many there are? You have k, k, right? kq. It's h. It's a combination, so ordering does not matter. kj, right? Now, when it comes to q, you can pick qq or qj. When it comes to j, you are picking j. So 1, 2, 3, 4, 5, 6. There are 6 of them. And there's this nice handy formula. You add n plus r minus 1 c r. That's how you calculate this h, this combination allowing repetition. Okay, what is r? 2. Okay, so 3 4 c 2 is equal to 4 times 3 over 2 equals to 6. Okay, so that's how you calculate that. Why is this formula true? I think I used to know, but I think I forgot how to prove it. All right. Why are we doing this? Well, just for fun, okay. But eventually we're gonna get into that graph theory that we said we'll do. I'm trying to think of this Pascal's triangle version in terms of h, okay, because C and H, they're kind of, I mean, they're not the same, but there's this conversion formula, okay, so this H can be very cool, okay, you have this kind of triangular relationship. Okay, So, well, let's just write it out. NHR is equal to N plus R minus 1 CR, and the binomial coefficient, the Pascal's triangle, uh, that formula was, by the way, you have the NCR plus NCR plus 1 is equal to N plus 1 CR plus 1. And also there is another handy formula, okay? NCR is equal to NC N minus R. It's symmetry. 1, 1, 1, 1, 2, 1, okay? 1, 3, 3, 1, right? So NC0 is equal to NC N, okay? That's like symmetry, okay? I want to derive some formula about H using this, guys, okay? How would I convert from here to there? What would be the formula if you do some algebraic manipulation? What would be the formula, like NCR is equal to something H something? That's what I want to find out, okay? Well, you have R here, right? That should be the same. And okay, how about this? A R. We have N plus R minus 1 is equal to A. And then N is equal to A minus R plus 1. Oh boy. Is there any way to do that? Okay. A is equal to N plus R minus 1. R and P is equal to R. Okay. And we are solving in terms of A and we are solving for N and R, okay? So N is equal to, we have R equal B, right? So that's good. N is equal to A minus R, which is B, and then plus 1, okay? I think we got it. We got it. So, oh boy. So, basically NCR is equal to N minus R plus 1 H R. Basically something like that, okay? Okay, that's the reverse formula. Okay, let's see if it's correct. Okay, let's make some example. Let's pick 3C2. According to this formula, you have n minus r, which is 1, 2H2. Okay, we know this is 3, right? 3C2 is equal to 3C1. Out of 3, you pick 1, okay? So, and this guy is equal to n plus 1 minus 3C2. Okay, yeah, so it is correct. Good. Very cool. Okay. Alright, so Pascal's triangular. So okay, so we have that, and then now we can come up with formula about H, alright, because using the formula, existing formula regarding the C. Okay, NCR, so now you n minus r plus 1h is equal to subtraction. What is this? The left hand side is this, n minus r plus 1 hr is equal to you add, and that we are using this formula, okay? You add and subtract 1. So you have 2n minus r minus 1. Oh, no. You gotta use this formula, okay? So we are going from C to H, okay? So n minus r plus 1. It is so confusing. This one minus this plus 1. So we have r plus 1, h, n minus r. Okay? Okay, we got it. So there's one equation for about h. Okay? And let's go upstairs now. The Pascal's triangle. Okay. So n minus r plus 1 h r plus n minus r plus 1 h. Wait a minute. You subtract and then you add 1. You subtract, so n minus r minus 1, then add 1 plus 1. Okay, so they cancels out. H, oh boy, and r plus 1 is equal to, finally, so you subtract and add 1. Okay, so you subtract, then add 1. N minus r plus 1 h, then just r here, r plus 1. Okay. Yeah, sorry, it's not a very pretty formula, but so what is NCR? If binomial coefficient in mathematics textbook in America, you denote it like this, n r with this, but it kind of looks like matrix, you know, so, or column vector. So yeah, I don't like that symbol, that notation. I prefer this. Okay, I think it's Japanese notation, but I don't know, I'm not sure. I know this is how it's taught in Japan and China, probably China too, but Korea definitely. Yeah, but who invented this notation, I don't know. Okay, it could be Europeans, it could be Americans, I have no idea who invented it first. Okay, all right, so yeah, I'm sorry it's not very pretty formula, but we got it. Okay, I just wanted to show it to you. And this it's something really cool. I just want to share with you how beautiful mathematics can be. So we've seen like Pascal's triangle, right? But in terms of this combination allowing repetition, it's even more beautiful. Okay, you can see this wave, this repeating pattern, some this array of these triangles. Okay, and we're gonna take a break and then we'll do it. Okay. All right. Okay, we're back. It's Sunday night. So it's not as exciting as Friday night, right? Because weekend is over. But it's just nice and quiet evening. After a long, long nap. Oh my goodness, my nap time was very long. Oh, uh, during the weekends or holidays, all I remember is brushing teeth. Single guy, very living very simple life. All I remember is brushing my teeth on the holiday or weekends, and sleeping. Anyways, so yeah, we just had example, right? Uh, let's just say A, B, C. Okay, A, B, C. Let's try to calculate 3 out of 3 allowing repetition. 3H1. How many are there are? Well, let's calculate it first. You add and then subtract 1. 3, C, 1, 3, right? Out of 3, we allow repetition, we pick just one of them. So yeah, A, B, C, right? Now, so that I was 3H2. Now it gets more interesting. Okay, you have we are not going to do this combinatorial equation. Okay, we just enumerate. Okay, you have A, then AB, ABC, and then you have BB, BC, and you have CC. You see, there's this triangle that gets smaller and smaller. Okay. I just want you to see this pattern. I just want to share it with you because it's something very beautiful. Okay. Here you have dot dot dot, right? 1 1 1. You have dot 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 and dot dot dot. Okay. Okay. How about 3H3? Okay. You have, oh my goodness, A. That's, let's take up the cross. Okay, let's do self-sacrifice. A, right? AAB, AAC. It's gonna take a lot of space though. Oh my goodness. A, B. We cannot do ABA because ABA is same as AAB, right? Because ordering doesn't matter. Then you have ABB, ABC. Okay. Now you have A, C, C. Okay. And then you have B, 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 C. And you have B, C, C. Okay. And then you have C, C, C. Okay, so, and guess what? This picture, you have AA, you know, AB, AC, BB, BC, CC. That picture is now being repeated right here. You see, AA, AB, AC, BB, BC, CC. Okay? Yeah, you can see it that way. Okay, let's because I'm gonna find out this nice way of a prettier way of representing this. Okay, because I used to know how to draw a very pretty picture out of this combination with repetition. This H, this function. Okay, it's very something very beautiful. Okay, I'm sorry if it's not as pretty as I want it to be. I used to know a prettier way to draw this. Yes, so you have 3 dot ABC, right? Now this is a 3H1, right? It's being repeated right here. Okay. Yeah, it can be seen as something like a three-dimensional pyramid, okay, of Pascal's triangle. All right. Yeah, that's what I'm trying to show you. Okay. Or even four-dimensional. Okay, so okay, let's try that. You have dot 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 dot. You have dot dot dot, and you have dot dot. Okay. So you have kind of a triangle here, triangle there, and just one line, I guess. Oh boy, right? So that's I just drew this, the one that involves A. The one that involves B is dot 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 dot. What's the best way to see this? How would I represent this? I used to know this, man. Oh, it's been such a long time. I used to know this. Oh boy, it was something very beautiful. Trying to get it back from my lapsed memory. It's been such a long time. Hmm. Should we just not do this? Maybe. Can we just not do this? I mean, maybe you can kind of see the point. Okay, so you have boy. Yeah, you have some bigger triangle here. Oh boy. B B B B B C. Yep, C C C. Oh boy. Yeah, I'm sorry. It's just not coming clearly. I cannot quite recall what I did in the past, but it kind of looked like this pyramidal thing. Okay, this three dimensional. You have triangle on top of triangle. It gets narrow and narrow. You have triangle. It's kind of like something like polyhedron or something. This kind of pyramid with at the bottom you have triangle, and you have smaller triangle, smaller triangle. Okay, and you can build this kind of triangle there, and this pyramidal shape with this using this H. Okay, and I used to know how to do it. I forgot. Okay, I don't quite recall. Okay, I have to think about this. I mean, if I'm gonna do it, because as of now, I don't recall. I'm sorry. So let's move on. Okay, let's. I'm sorry. Maybe we get back to this later, some other time, or not. I don't know. Just wanted to share with you. Okay, but if you get it, well, please share it with other people, okay? Because something very beautiful, okay? I'm sorry. I I'm sorry if I failed you. And okay, let's just do something easier. Graph theory. Okay. Okay. So at first we have this person A. Okay. Well, let's do lowercase because easier to write. Kind of cursive, lowercase. Um, there are two cases. Why? Two cases. Does A know himself or not? All right. Newborn baby. He has no idea who he is, right? But as this baby grows up, yeah, let's say there's this remote island, abandoned baby in a remote island. Okay. As he grows up, yeah, learn who he is, right? How about a dog, a cat, or adult dog? Does a dog, mature dog, know who he is? For example, if a dog look at the mirror, does he know the image in the mirror is himself? It's kind of interesting question. Just yeah, I mean, self consciousness, whatever you call it, ego, whatever you call it, right? Is there any way to know it? No, because I've seen some animal experiment. When I grew up in Korea, we have this TV show, okay, about a quiz about animals. Okay, it's a very educational, instructive TV show. And it was a lot of fun. Okay, it wasn't just for children. No, basically, they would bring, I think, celebrities, right? And there's this we ask and they ask questions to these people about some animals. Okay, so you have this footage of animals, some experiment maybe with animals, and the question was, and they stopped the footage, and what happened next in this situation? Okay, with these animals. Okay, it could be a natural setting, or it could be artificial setting with the animals. So one of the artificial setting in this quiz was this. There's this dog, okay? I think it was like German Shepherd, something like that, okay? It's an adult dog, okay? And dog has some bone, piece of bone that a dog really loves, right? A dog has a piece of bone in his mouth, is carrying it, and then they showed a mirror. So the dog sees himself, and it barked at it, and it dropped the bone. Okay. And the quiz was, okay, what if we show the mirror the second time? Is this dog gonna remember? Or did the dog learn something? Okay, so that was the quiz. What happened? So second trial, the dog also the same dog has this bone in his mouth. Okay. The first time when it looked at the mirror of himself, okay, mirror image of himself, it barked at it, the mirror image of himself. So obviously he doesn't know this mirror image is him. Maybe it was the very first time he looked at the mirror. Okay, I don't have a pet. I don't have a dog, so I don't know how things happen between dogs and mirrors. I have no idea. Okay, how dogs behave around mirrors. I don't know. So the first time, yeah, this dog barked at himself in the mirror image because he thought it was some other dog, right? So it dropped the bone from his mouth. Now, the quiz is this. Okay, the same dog, it also has the same bone. Now, maybe next day, okay, we bring the mirror again so that this dog sees himself for the second time. Now, what do you think will happen? That was the quiz. Okay, so we're gonna take a break. I want you to take a shot at the answer. Okay, it was very interesting. Right. Yeah, I'm gonna wash my face. Okay. Uh, Something's in my eye. Okay, we're back. So, yeah, I'm not drinking because I drank too much. Okay, earlier, so I don't feel like drinking. Okay, I think the way we construct this pyramid with this H, you know, the combination allowing repetition, probably you have to do something like this. Like, what's the smallest number? Maybe 1H1, maybe. You add 2 and subtract 1, so this becomes what? You add these two and subtract 1C1, something like that. Okay. And then you have 1 Okay, so in terms of combination, okay, NCR, right? R, the maximum R range of R. So R is between 0 and N, okay? R cannot be more than N, okay? But in H, because we are allowing repetition, this can be any number. Can it be 0? Yeah, probably. What is NH0 is equal to what? You add and subtract 1, N minus 1, H0. Yeah, I mean, C0. Yeah, you can do that. Okay. This number can be as big as like 100, or it can be. Why? Because what is 1 H3, for example, is equal to, you add this 2, subtract 1, C, C, 3C3, 1, like A, okay? Yeah, this can be a very big number, okay? There's no upper limit because we are allowing repetition, okay? Yeah, I guess you can construct simple case like how it behaves, okay? When this n is equal to 1, then you go to next step, n is equal to 2, then 3, blah, 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 okay? Probably then you can construct this pyramid, okay? I will let you do it, okay, as a homework, if you would like to do it. It's optional, extra credit, whatever, okay? But please don't spend too much time on it, okay? Because we have better things to do in life. But it's a good exercise, okay? Yeah. Okay. Let's do humanology, okay? Graph theory. So, yeah, if there's... Okay, what's the answer to that quiz? The dog barked at that mirror image of himself again. But it did not drop the bone because it learned a lesson that, oh, I can bark and not drop the bone at the same time. Okay, I can retain the bone in my mouth and also I can bark at the same time. I can bark without dropping the bone. That's what it learned. But this dog still didn't learn this mirror image is himself. It still thought it's some other dog. Okay, so it learned one lesson but not the other lesson. Okay, so that was very interesting. Okay, and all right. So that's, we have two cases, right? With A know who he is and A know who he is, and but A does not know who he is. Okay. What about, there are two people, A and B. When A knows himself, we denote this as A dot. Okay. A knows himself, and B, they don't know each other in this island. Maybe it's like North Korea, South Korea, or West Germany, East Germany, whatever. Okay, there's this huge mountain range in the middle of in the middle of this island. Okay, the island is huge mountain range. Okay, you know this blue pen is wearing out. I better buy a new set of pens, markers. Okay. So there is A and B, and they don't quite see each other, and they don't know each other's existence in this island. It happens all the time, right? Somebody is living in Alaska, and even inside of Alaska, there's this remote village from where I live, and a person living in that village and me probably will never see each other ever in our lives, or we never see each other on television. So I have no idea. I don't even know the existence of that person. Okay. So yeah, we are modeling some human relationship. Okay. In terms of graph or combinatorial enumeration. Okay. A know who he is, and B knows who he is, but they don't know each other. Okay. Here, yeah. So A dot means A with A who knows himself, A without dot is A have no idea who he is. Okay, maybe amnesia, or maybe A is just a baby. Okay, but guess what? Yeah, so we continue with the computer enumeration. Okay, and then A, B, A dot, B without dot, and A, B dot, A without dot, and B without dot. Okay, so yeah, 4 cases, right? Whew. Now, it's exponential explosion, exponential growth. We have, so far we have already 4 cases, right? My goodness, that's why we gave up last time, because it's just growth is too fast. But for the sake of argument, let's just throw it out. Okay, we have A. In this case alone, we have A, B. They are adults who know who they are, but A knows B, but B does not know A. Now here, A, B, B knows A, okay, but A does not know B. What if they know each other? And so there are 3 cases, right? Each of them. So 4 times 3 is equal to 12. Okay? E. When there are only 1 person, there are 2 cases. When there are 2 people, you have 2 to the second times. How does C come from? Where does C come from? It's like this. A to B, you have AB, B to A, BA, and then bidirectional. I'm trying to formulate this as a combinatorial problem, okay, so that we can take advantage of all these formulas in combination or permutation, factorial, okay. By the way, n factorial is 1 times 2 times blah blah times n, right? Is npn, okay. Yeah, it's a special case of this permutation. Just to point it out to you, right? Why? Because it's like what? N factorial over n minus n factorial, right? Is it? Yeah. And 0 factorial is 1, okay? So it's just by definition, I guess. Anyways. Yeah, we want to know where the C comes from, okay? So we're counting the ways, how many configurations there are. How about when there's A, B, C, okay? We want to find out general formula, okay? A, B, C. How many ways? Well, actually, you know what? There's this case. A, B does not know each other. So actually, this is not 4. This is not 3. It's 4. Okay. Sorry. AB, BB. Anyways, so you have ABC, okay. First case that nobody knows each other, okay. ABC. How about AB? Oh, okay, okay, okay. We can do on top of that, right? So it's kind of inheritance concept, all right. So when AB, when we only have AB, there are four cases, right? Like directional, unilateral direction, bidirection, and no connection whatsoever. Okay. How about C? We throw in C. We have let's say A and B, they don't know each other. Okay. We can have this. We can have that. We can have this. Or we can have this. So 4 here, okay? And we're gonna count the same way the relationship between B and C. So between A and C, there are 4 cases. And between C and B, there are 4 cases. Okay? Actually, we need to multiply. Okay. Because in this case alone, there are 4 of them between B and C, okay? Here, 4 of them between B and C. Yeah, C knows A, right? But between, how about the relation between B and C? There are 4 cases, 4 sub cases, okay? That's why we are multiplying this one. And for each of them, now we are beginning to see the pattern, okay? This one gigantic case is when A and B does not know each other. But there are 4 cases between A and B, okay? Now we got it. We got it. Okay. So this letter 4 is about arrows, and this initial 4 is about dot or not, no dot, okay? My goodness, this is complex. It's a very difficult combinatorial problem, alright? Oh boy. You're just counting the numbers. This is about dot, okay? So your 4 cases where there's dot or no dot, okay? The 4 cases about dots. For each of those cases, we have 4 ways to draw arrows, okay? So that's why we have 16 of this. Alright. Actually, dot is, we have to remember, dot, this is same as a dot, right? But actually, it's an arrow. So it is combinatorial problem, okay? So arrow is just a. We are, okay, now I think we kind of get it. Because it's maybe it's permutation allowing repetition. Okay. Or maybe not. Oh. boy, I don't know how to formulate this. I have no idea. Okay. Oh boy, yeah, this is very very challenging problem. It's actually giving me headache. Okay, I may need to take some ibuprofen. Well, because when you oversleep, yeah, sometimes it gives you very light headache, right? Ah, boy. So initial four is about A and C, and it's about these arrows, and we have four of them because it's B and C, and then four of them because you have a between A and B arrows, right? We haven't counted the dots yet, okay? So we gotta multiply by, I think it should be 8. 2 times 2 times 2. 2 to the third, okay? So tentatively, okay? 4 to the 3, C, 2, okay? So out of 3, we are picking the 2, okay? Multiply by 2 to the 3, okay? That's our tentative formula, okay? So 4 to the n c 2 times 2 to the nth, okay? So that's our tentative formula, okay? Here n is equal to 2, okay? So 4 to the 2c2, 4 to the first, and n is equal to 2 to the 2. So yeah, we got it, okay? And one C2, well, we don't quite define one C2 because 2 is more than 1, right? So here we just write it as 2, okay? Because whatever. Yeah, so this is about dots, okay? This is about dots. This one is about dot, okay? So 2 to the 2, okay? And the arrow part, yeah. There are 4 arrows, and we are just picking 2 out of 2, okay? Okay. Yeah, well, I think that we should just satisfy ourselves with this, okay? It makes me dizzy, okay? Just I want to point out to you where a special case, okay? Oh, yeah. Well, at least we made some progress, okay? Because we found some nice formula there. I think that's correct formula, okay? All this, relational graph theory, okay? Oh my goodness. Let's say A and B, okay? And there's the baby. Baby have no idea who he is, but probably baby recognized his mother, okay? So mother knows who she is, but baby does not know who he is, okay? But baby recognized the mother, okay? Does dog knows who he is? Is self-consciousness, self-knowledge? Probably self-knowledge is something unique to human being. Okay. What does it know? What does it mean that I know who I am? Probably self-knowledge, knowledge about oneself. Okay. Simplest. Let's not too overly make it complex. Okay. Let's start from something easy. Do you know who you are? What does it mean? Well, do I know who I am? Yeah, I know what my name is. I know what I look like. Meaning, I know how to spell my name. And when I read my name, say on a report in my job or in a school, my report card, score sheet, right? Score report, my grade report. Yeah, oh, yeah, that's my name. Okay, so this should be report about me or, yeah, I recognize my name. And okay, and I have yearbook, right? High school yearbook, whatever, right? It has, let's say, I flip the pages and oh yeah, I see myself, my picture there, right? Or there's just holiday pictures. Okay, I went go to a holiday party, right? And there's this photographer, just one of my friend acting as a photographer that day in that party, and they take multiple pictures, and he send it all to everybody, right? Email. Okay, and I look at all the pictures. Oh yeah, there is me over there in that picture, but the other picture, another picture. Oh, I'm not in this picture. Yeah, that comes self knowledge. I know what I look like, or even voice recording, right? This video camera in this holiday party, right? And they just send out the sound and no images, just sound. Yeah, that's my voice. Yeah, I recognize my voice, the way I look visually or auditorily, my voice, and I know what my name is. Okay, I recognize my name in a score report, whatever. Okay, or in the mail or email. Yeah, I recognize my email address, whatever. Things about me, my social security number, my address, my phone number. Yeah, those are the information about me. Now, how about a dog? I guess if I call, let's say, dog's name is Happy. Okay. Hey, Happy. Your name is Happy. Or I don't know how you spell a dog's name. Maybe you put Y here or IE there. I don't know. I don't have a dog. I never had a one. I had when I was a child. Yeah, we had the dog maybe for a couple of hours or a couple of days because it was kind of lost and it was pure, very beautiful, purebred, pedigreed kind of dog. So we wanted to find the owner of that dog. So we had that dog for a couple of days or a couple of hours. I don't remember. Okay, but it was a fine bred dog. So, and how do you train a dog so that it recognizes its name? Probably a dog recognizes its name when you call the dog. You have two dogs, right? And Happy and Puffy. How about that? Puffy. Let's say you have two dogs. Okay. Puffy, come here. If you say that, do both of dogs come to you or only Puffy comes to you? I don't know. I don't have dogs. Yeah, many of my friends have dogs. My guess is they recognize their name. Okay. Maybe only Puffy. Hey, Puffy, come here. Maybe only Puffy comes. How about cats? Do they know? I have no idea. Probably they do, right? Happy, come here. Then maybe only Happy comes and Puffy doesn't. I don't know. Do they recognize their name? And how do you train the dogs to recognize its name? Is it repetition? Maybe, maybe. I don't know. Okay, so, but is it because this dog Puffy does it really know what its name is? Or when say Puffy, Puffy, does it does this dog recognize, I mean, interpret this sound Puffy as some kind of language? Yeah, we are kind of being philosophical, okay, right now. It's a very philosophical discussion here, okay? Not about knowledge. So I guess you can call it epistemology, right? Yeah, we are doing epistemology here. Philosophy about knowledge, all right? So, when I call, hey, Puffy, Puffy, um, does the dog come to me because it knows its name? Or does dog interpret this sound Puffy as a language or vocabulary to come to me? Like, for example, come here. To dog, one hypothesis is this: come here. Well, and Puffy, maybe they are synonymous. Maybe dog interprets all the three languages, like this sound and Puffy and come here. Maybe this dog interprets those three different sounds as synonymous. Maybe they are the same thing to the dog. Okay, that's what I'm trying to explain to you. That's one hypothesis. Hypothesis. Okay. Yeah, it's a signal to. It's an order, command to this dog that yeah, I shall go to my owner, my master. This Alaskan Asian guy. Okay, who give me food. Okay. Maybe it's that. Or second hypothesis, maybe the dog knows it that Puffy is its name. Maybe it has some self knowledge. Okay. How about an ant? How about a dragonfly? Do they have self knowledge, knowledge about itself? Or are they some kind of biological machinery that feels pain, pleasure? Okay. Let's think about that, all right? It's a very interesting philosophical question, okay? So we're gonna take a break and we'll do some more, all right? Self-knowledge, very interesting discussion here. Okay, we'll be back. Okay. Yeah, sorry about long break, but I'll be back. Okay, we're back. Sorry, on a long break. So basically, we're not gonna call it self-consciousness because that's too psychologistic. Okay, we don't like psychologism here. Okay, it is dirty. All right, it's just self-knowledge, knowledge about oneself. So why don't you say it knowledge? I'm conscious of that. It means same thing, exact same thing as I know that. Okay, we don't need to introduce this fancy words like consciousness. Oh, disgusting, right? Freud and all that psychological garbages. Psychology is not a science, it's not a religion, it's just garbage. Just like gayism. Okay? Psychologism, gayism, yeah, one of the same kind. Okay? It's not science, it's not religion, it's just garbage. Junk. Okay, that's what those are. Okay? So, yeah, self knowledge, okay? What does it mean that one knows oneself? Okay? Yeah, we'll start with just name. Alright? Name, figure, visual, figure. Name is kind of like, it's a little metaphysical, right? You can see your name, you can hear your name, somebody calling your name, right? It's a visual, also it's auditorial, so it's kind of like metaphysical, okay? Language, right? Yeah. So philosopher like Wittgenstein, he studied language. Yeah, I think it's important contribution. He emphasized, he put language on the spotlight in philosophy. Okay, so that's a contribution. It's important contribution, but kind of small contribution. Okay, so let's not overrate Wittgenstein. Okay, because he talked shit about Georg Cantor. Set theory. He said, "Oh, set theory. Oh, garbage." Where he was wrong. Okay, and also the Kronecker, he was wrong. There, criticized set theory. Maybe it was constructive criticism because maybe Georg Cantor refined his set theory after their criticism. Maybe it was constructive criticism. I don't know. I don't know the details. Okay. Maybe it was correct criticism. Okay, I don't know. All right. I don't know the details. Anyway. Maybe they didn't criticize set theory, but maybe they criticized the infinity theory. of Gary Cantor. He does a lot of infinity. Yeah, mathematical infinity is very interesting. Okay, because we have infinity, right? Infinity symbol like x goes to infinity. What is limit of x squared? Or you can have limit x go to infinity 2x. Okay, so you have this x squared parabola and 2x or just x. Okay, right? Whatever. I'm sorry, it's not quite in scale, but up to this point, yeah, x was more than x squared. Okay, but x after 1 this point, x squared is a lot faster. The speed of infinity, okay, is bigger than x. Okay, because it's like now it's second order. So yeah, not every infinity is the same. That's what I'm trying to say. There's different speed of infinity. Okay, different growth. Okay, yeah, in computer science, also in mathematics, we have big O notation, small O notation, blah blah. Yeah, they deal with that, the speed of growth. Okay. Anyways, so it's well explored area. Okay, and uh, let's get back to this self knowledge. All right. So yeah, baby, he doesn't know who he is, but he knows recognize his mother. All right. Our hypothesis is that animal does not have any self knowledge, just like a baby. Baby is like animal, okay. All it does is eat, sleep. Yeah, it does recognize its mother, but animals probably they don't have self knowledge. This experiment, dog dropping the bone, it they the motivation for that experiment, animal experiment, is this parable, this child's story for children. There was a dog was crossing the bridge. It has some food in its mouth and bone, and it looked down, and there was this river and or pond under the bridge, and the dog looked itself and barked, and it dropped the bone into the water. Okay, so that was the story, and I don't think dog has any self knowledge, okay, or just like baby doesn't, okay. Probably dog recognizing its name, probably it's a vocabulary for the dog, okay. It's a signal. It's an order, command. Like come here. It's a synonymous as come here. Puffy, dog probably interprets as come here, come to me. Okay, I think that's my guess. Okay. Anyways, so we have all this different configuration. Okay, graph theory. It makes me dizzy. So yeah, let's just stop there. Graph theory, it just gets too complex, overwhelmingly complex. So, but at least we made some progress there. Okay, we made some progress there. We found this formula. Okay, I think it's correct formula. Okay. I'm kind of out of it because I had a very long nap and I'm feeling lethargic, inactive. Okay, and it's like what time is it? So we may just wrap it up for today, okay? Because 10:30 Sunday, and yeah, I don't really feel like doing anything. I just wanna eat, watch some you know Twilight Zone episode, and yeah, I don't quite feel like doing anything. And we'll turn off the heater. Uh, oh boy. We can read some books. Oh boy. Ah. Graph theory. I'm sorry, I'm not being very productive here. Well, let's just twiddle our thumbs. Okay, so you have A, B, and C. Okay. I'm feeling so lazy now. Okay. Oh boy. Let's do graph theory, okay? Let's not be too lazy. Oh boy. Because yeah, I think it's a fertile ground. It's just I'm feeling lazy. You know, maybe I should drink just a little bit. Okay. By the way, I'm too hot. I'm being overheated. Oh. Boy, it's hot. Because I don't want to just eat because I had this long nap, right? And I'll feel guilty if I just eat because the concept here is I gotta earn what I eat. I gotta earn the right to eat. I don't want to just eat. I want to work and play rather than just play and play. You know. I gotta earn the right to eat. Okay, so okay, I'm gonna drink just a little bit. Okay. So what should I drink? Uh, what would be my drink now? Some random stuff, I guess. All right, let's bring back the vodka, and let's do some work, graph theory, because it's a very fertile ground. I was feeling lazy, but you know, let's live our life to the fullest. They say that in terms of like having sex, partying, right? Oh, let's live it to the fullest. I think it's a bad way of saying that. Live to the fullest. Let's work. Okay, do something productive to the best we can. Let's give it our best. Okay. So, let's say, well, we can start with two. Sure. I mean, unless you are a baby or have some amnesia, then you don't know who you are. Yeah, a lot of novels, TV shows, they deal with that situation, amnesia. Somebody has an accident, he doesn't know who he is. Yeah, it's fairly common theme in a movie, novel, right? Amnesia, right? He has no idea who he is, but there's this dead body right next to him. Oh my goodness, what happened? Did I kill him? What happened? I don't know who I am. I don't have any recollection. Okay? I just woke up from sleep and my head hurts and I look and there's dead body. Did I kill him? And who am I? You know? Whatever. Then he got arrested. He called 911 and he got arrested for murder. Hey, I have no idea. I don't have a recollection. I don't even know who I am. Okay? Whatever. So, okay. You have A and B, okay, but I think it's safe to assume everybody knows who he is because amnesia is very rare, right? And yeah, so we don't have to concern ourselves with that dot or self knowledge, blah blah blah. And it's an interesting discussion, but most people know at least what their names are, what they look like, okay? Dogs, do they know who they are? Why should we care, right? Babies, well, they will grow up. They will know what their names are, what they look like. Yeah. But, yeah, so self knowledge, yeah, is interesting to discuss for a little while, but that's that. Let's move on, okay? But before we move on, just one more thing. A person changes, right? We age, so we grow up until what, 20 years old, right? After that, it's downhill. We age, we get old, okay? What's the maximum? Maybe 30. You grow until you're 30, and your body kind of start to degenerate as you age, something like that, right? So yeah, you change, right? So self knowledge, I guess there's some more. Okay, let's talk about self knowledge a little bit more because I guess it's a fertile ground to green pasture. Okay, so self knowledge. Now it's kind of getting cold now. Yeah, I don't adjust to changing temperature very well. So self knowledge, okay. There are this Twilight Zone episode where this aging actress, and she used to be a very famous celebrity, but now she's old, so she doesn't want to get old, and so, or me, okay, I'm losing my hair, right? But I don't want to lose my hair. Or some teenager, okay, teenager boy. Oh, I don't like the fact I have this mustache with something new. I don't want to grow up. I want to be a child forever, okay? Yeah, we have those moments. We either grow up and maybe we hate it as a teenager, or we get old, or maybe we hate the fact that we get old, okay? Or the wrinkles, or losing hair, or whatever, okay? Uh, so, because we change as time goes by, right? And sometimes it's a good change, positive change. Sometimes it's a negative change, the kind of change that we don't like. But at least we know our new self. Okay, so self knowledge, yeah, we know who we are mostly, most of the times, right? What are people with some madness, insanity, dementia? What if I think I am the president of the United States right now? Okay, well, that's a mistaken knowledge, right? False knowledge because I'm not a president. Okay, but if I think that's who I am, then well, that's a wrong knowledge. I'm mistaken. Okay, but if I say I want to be the president in 2021 January, that's what I want myself to be. Okay, in the future, self knowledge. So what is this? Is there's knowledge, right? Knowledge is about past. What is present? There's no such a thing as present because now, now, now is that single like 0.0001 second a moment. actually it doesn't even exist. Present doesn't exist. It's either future or past. Because the time, what time is it? 10 o'clock, 31 minutes, 35 seconds. It moves up. It becomes 35, 36, 37, 38 every second, right? Time ticks, right? But what about 0.1 second? You have this stopwatch, right? It has this 0.0 second, 0.00 second, blah, 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 right? Yeah, so present, there's no present. What we mean by present is like now, present is close past and close future. Okay, this range, maybe 5 minute range. That's what we call now or present. But conceptually, mathematically, it doesn't exist. Okay, because this second we can always divide by it's the law of infinitesimality. Okay, we can divide by 0.000000001 second. Okay, so it doesn't exist. Just like what is the smallest particle? There's no such a thing as smallest particle because we can always divide by 2, divide by 2, divide by 2. The law of infinitesimality. Okay. So it's not a physics question, it's a philosophical question. All right, it's more like ontology. Okay, study about being, study about entity, ontology. Okay. Yeah, just diet soda pop. That's what I feel like drinking. Not much alcohol. Yeah, I don't kind of feel like drinking alcohol. Okay. So, by the way, you watch Twilight Zone, you know, the Rod Sterling, you know. There, people drink alcohol, smoke cigarettes all the time there, okay? The Twilight Zone episodes, that's how America used to be, okay? And it's a good thing, okay? So drinking alcohol, smoking cigarette, as long as done properly, it's a good thing, okay? Anyway, just look at the fruit. You know, just like Jesus said, yeah, you can tell the tree by its fruit, right? Yeah, fantastic TV shows, right? All this, just like this Robert Zemeckis, director of the what, Forrest Gump, or director of Back to the Future series. Yeah, it was Bob Gale and Robert Zemeckis, right? So Robert Zemeckis, yeah, he said, yeah, all this, most of the TV shows, movies, even some songs, like Real Slim Shady, Please Stand Up, or I'm the Night, whatever. Yeah, they're all based on this Twilight Zone series, okay? And how was it created? Well, Rod Sterling and his colleagues, yeah, they smoke cigarettes, they drink alcohol. So that's the fruit of that. So, yeah, proper drinking, proper smoking is good, okay? Anyway. Okay, so there's no such a thing as now, okay? There's only because this fleeting moment of now, it always moves on, okay? 0.001 second, blah, blah, right? So now, point now doesn't quite exist, okay? It's a range of close past and close future. That's what we call now, okay? Present. So it's either past or future, okay? So this concept of zero is very, very special concept, right? Okay, so there, the minus plus. So time is one dimensional, okay? And also it has only one direction. Time, yeah, we can look back, we can remember, or look at the history book, but time itself only goes forward, one direction, okay? I mean, we can think about this fiction, like Back to the Future, time machine, right? Yeah. Interesting concept, but it's not realistic, right? Okay. So time goes only forward, okay? And the future, we don't have any knowledge about the future, okay? Because will the sun rise tomorrow? Probably, right? I guess, yeah, it's a projection, right? Um, okay, what are some possibilities that sun will not rise tomorrow? Okay, well, maybe there's big meteor hitting the earth, or or even bigger meteor hitting the sun, so earth get destroyed or sun get destroyed, or then yeah, sun will not rise. Actually, sun doesn't rise, it's earth rotating itself, right? So, but if earth get destroyed tomorrow, then there will be no sunrise tomorrow, right? It's conceivable. Okay, so yeah, future we can make some prediction based on repeating pattern in the past that we have knowledge of, right? So knowledge is about past, okay? Future, yeah, we can predict, but we could be wrong. It's not a true knowledge. It's a guess, educated guess, or uneducated guess, okay? Knowledge is about the past. Why? Because future doesn't exist yet. All right? Not yet. Okay, here is called, right? 1 second later, yeah, I can move it over there. Okay? But that future didn't exist like 5 seconds ago. Okay? So future is being written as now, as of now, present, present, present. And future becomes the past as soon as this clock needle moves beyond that. Future becomes the past every second. Our future is becoming present and the past. Okay? We're just having some fun with philosophy, okay? Philosophy of time. Anyway, so let's get back to this graph theory, okay? The fertile ground. Okay. Uh, so yeah, most people know who he is. Future, our future self. Yeah, I mean, in God's point of view, yeah, future is fixed. He knows what the future will be. But in our eyes, because God lives in a higher dimension, right? At least in theory, okay? But ourselves, we don't see the future. It's not fixed in terms of our eyes because that's the dimension we are living in. We live in 3.5 dimension, okay? 3 dimension XYZ space and zero point 0.5 time because we can look back in the past, but we cannot see the future. Okay, so that's why it's only 0 0.5 dimension. Okay, we have no knowledge of the future. We cannot see the future. Okay, yeah, it's true. We can imagine all different things, different alternative universes, future courses, but only one of them end up happening. Okay, so that's why we are saying future is fixed in terms of God, from God's eyes, God's point of view. That one thing that ends up happening, okay? And God knows what that is. We don't, okay? It's just two different ways of looking at thinking about the future, okay? First, yeah, future is not fixed. We don't know what it will be because we cannot see what the future will be, okay? 1 minute from now, I can be outside smoking cigarette, or I can be just talking here. I don't know, okay? But only one thing end up happening, right? So one way to look at it is future is not fixed. Second way to look at it is future is fixed. We just don't know what it is. We just cannot see it. Okay, it's like in a black box. Yeah, there's something in there, but we just don't know what it is. Okay. Yeah, two different ways of looking at it. Okay. we're gonna take a break, okay, and then we'll. So knowledge, okay. So self knowledge. Uh, I know who I am now. It means I know who I am. Like I know who I was in the past. Some close past, like 10 minutes ago. I know who I am, right? Because I'm constantly changing, right? So because there is no such a thing as now or present, okay? It's just heuristics, approximation, just easy way to say, yeah, close past, that's now, okay? Yeah, who I am now, yeah, my name is blah blah, I look like this, but at the same time, I change. I mean, the way I look, yeah, it changes every day, right? The number of my hair, yeah, I'm shedding hair, some new hair grow, but the speed of me losing hair is faster than speed of getting new hair growing. So I'm losing hair net total. Okay. So but yeah, I know what I look like 10 seconds ago because I'm looking at this camera and there's this in the laptop screen. Yeah, I see myself just like looking at the mirror. Okay. And but my future self, like 2 years from now, yeah, I want to be the president. That's not a knowledge. That's my desire. What I want to be. Okay. So there's knowledge of me, who I am now. Okay. Some close past and close future. Yeah, I will be paper pusher guy working in an office, right? But 1 year from now, I don't know what I will be doing. Hopefully, I become famous so that I can become president 2 years from now. But that's what I want to be, the president, okay? It's not a knowledge, it's a desire, okay? Because future is not set yet. Future doesn't even exist yet, okay? Um, from one point of view, one theory, okay? One way to looking at it. And probably that's more convenient than saying future is already fixed. Why? Because um, I'm not God. Even if it's fixed, I don't know what it is. So what's the point then, right? So yeah, it's more convenient to say, oh yeah, future is not fixed, and something that doesn't even exist yet. I have to make it happen, right? And yeah, it's something I want to be, so it's a desire, but it's not a knowledge, okay? Because it doesn't exist yet, right? So that's the future. So yeah, desire, planning, same thing, right? Okay. So that's knowledge versus desire, okay? Yeah, desire is always about the it's kind of like opposite. So this is now, this is desire, okay? Desire is always about the future. Knowledge, opposite. Knowledge is always about past, past, future, okay? I'm just being lazy, okay? Knowledge is always about the past. Desire is always about the future. Something you want, and it's about what you want. What do you want? Yeah, I want to have a toy, a brand new car in the future. Not to know something is always about the past. So knowledge and desire, they're kind of like in this time dimension, they're the temporal opposite, antithesis, antonym to each other, the opposite concept. Okay, what you want, what you know. Okay. So yeah, we are discovering something new. Good. We're getting some job done here. Okay. Because I don't know if there has been any philosophers who realized the significance of these two concepts in conjunction with the time axis. Okay, it's simple, but it's something very fundamental. I'm not sure has there been any philosophers who talked about this. I don't know. I mean, I didn't major in philosophy. I have a couple of philosophical books, but do I read them like cover to cover? No, not really. Just flip through pages sometimes. We're gonna take a break, okay? So it's been 2 hours. I think we'll do full 3 hours, okay? Because yeah, let's not be too lazy. Okay, let's give it the best shot, okay? Let's hit it with the best shot, okay? All right, we'll take a break. All right, we're back. So let's continue some more with this, okay? Before we do the graph theory, okay? Uh, so difference between past and the future, okay? Because now, present doesn't exist, all right? Future, well, it's not fixed. It doesn't exist either. It's in terms of existence. Now we are talking about existentialism, right? We talked about ontology, epistemology. Epistemology is the study of knowledge. Ontology is study of entity, being. Existentialism, I don't know too much about it, but we just call it existentialism, okay? Whether something exists or not. Study of existence. Something very cool, right? You were Jean-Paul Sartre and Camus, something like that. French philosophers. Cool people, right? Oh, it's France. Oh, yeah, they're artistic and philosophical. Oh, so high-nosed, classy, whatever, okay? I've been to France. Yeah, these cool people. Beautiful country, right? Paris. Yeah, I've been there. Not for long, though. Anyways. Okay, so philosophy, existentialism. Okay, it just sounds so cool. Existentialism. Ooh. we know past exists, right? Future, yeah, it will exist. We can tell. I mean, is the universe will just disappear? It's possible if God decides, you know what, I'm gonna get rid of universe. I'm going to get rid of all the universe, the galaxies and stars, and I'm gonna get rid of it tomorrow. It will become nada, nothing. Just like the state where before I created the universe. Who knows? Maybe God will decide that. Yeah, I regret having created the universe, so I'm gonna get rid of it. It won't be Noah's flood. No, I will just get rid of it. I will erase the existence of the universe because I don't like what's happening in the universe. It's boring. So let's get rid of universe. We go back to the drawing board, just like before, the time before I created the universe. Yeah, non-existence will return universe into non-existence. I'm gonna get rid of the universe tomorrow. But before that, I'm gonna take a nap. Who knows? God is known to be capricious like that, right? It can happen. But unless that happens, probably future will exist, right? So, existence of the future is projection, is our guess. We think future will exist. We don't know what shape it will be, but we don't know what's going to happen tomorrow, but probably something will happen. So we can project, we can guess it will exist, but the details of the future, what's going to happen tomorrow, what we're going to read in the news tomorrow, we don't know. Okay? It exists, but it doesn't. So it's like 0.5 existence, something like that, okay? Yeah, probably will exist, but we don't know the details. Okay? So yeah. Or future, it could be also desire, or it could be prediction. Okay? Doesn't quite exist yet. Okay? Past, yeah, it does exist. So, and we cannot change the past. There's another distinction between past and the future. Future, yeah, it's malleable, it's changeable, right? Like tomorrow, yeah, I will go to work tomorrow. Tomorrow is Monday, right? But what if I decide not to go to work tomorrow? What if I just decide, you know what? Tomorrow I'm gonna move out of Alaska, go back, return to what? Lower 48 or lower 49, or maybe I go to Hawaii or Florida, where it's warm. But nowadays Alaska is very warm. Yeah, you know what? I'm gonna just stay. Okay, so yeah, future is changeable. Okay. Yeah, I'll go to work tomorrow. So what do I have for lunch? I can go to McDonald's or Burger King, or should I go to some Chinese food restaurant, or Subway sandwich, or yeah, it's malleable, changeable, right? Yeah, but past we cannot change, all right? And future, we can invent something new, make brand new science, brand new theory, brand new equation, discover something. Okay, so something creative things. Past, we study what's already been done. Okay. Now, let's talk about this folly of psychologism. They say, oh, it's like hocus pocus, this crystal ball. They make all this bogus, stupid connection. It's all fiction, okay? It's all made up. Oh, you have childhood trauma, that's why you are now like this. No, that's wrong, okay? That's false, okay? That's a wrong theory, misknowledge. That's a wrong knowledge, okay? The only thing that, and so psychology is that backward looking, it try to tie you down to your past you try to forget, you need to forget. It's very unhealthy way of thinking. Okay, that's why I'm saying 99% of psychologism is satanic. It's destructive. It doesn't help you. It makes you worse. Okay. You need to forget about the past and you should be forward looking. Okay. Do you have any problem today? Yeah, well, let's fix it. Let's be better. You forget about anything that happened in the past. Okay, you need to move forward, look forward. Okay. And so, what's the connection between past and present? Is this: whatever painful experience you may have, yeah, it made you a stronger person. Okay, so painful past is actually a good thing because it disciplined you. It made you a stronger person. Okay. Oh, trauma. Oh, no, no. Don't go there. Okay. Don't think that way. It's a bad way of thinking. So psychologism, you need to forget about it. Okay. It's poisonous. It's like snake venom. You need to get it out of your system. Okay. Psychologism, you have to forget everything you learned in psychology because it's bad for you. Okay. It's something very toxic, very destructive, and very poisonous. It corrupts your mind. Psychologism, okay, it's a demonic, it's satanic, it's devilish, right? Psychologism is a bad thing. Okay, you need to forget about it. Okay. All right. So yeah, how do you discipline yourself? Diet, fasting. What what am I doing now? I mean, I wanted to eat, right? But I'm working. Yeah, labor, hobby. Yeah, proper consumption of alcohol and cigarette. Moderate consumption, right? Just look how slow I'm drinking, right? I never take a shot like no, I never do that. That's not a good way of drinking. You drink slowly, okay? So you sip it every once in a while. Okay, proper way of drinking, smoking, and regular exercise. Okay, very important. Yeah, that's how you discipline yourself. You study, right? Yeah, I studied tensor calculus like 2 days ago, watching this YouTube video. Okay, or sometimes in the internet, right? Yeah, you study and exercise. You go to work, right? Yeah, that's how you discipline yourself. You have to stay fit. Okay. All right. You have to have some ambition, future plan, okay, career goal, okay, that kind of stuff. So enough with that. I don't think we have anything more to say here. Okay, so we do go back to graph theory. Okay. Uh, so you have two people, right? Okay, you have two people, A and B. You have four cases. Maybe A and B, they don't know each other. We assume A knows who he is, B knows who he is. Okay, Adam, Barbie. Okay, yeah, she knows who she is. Oh, okay, Adam and Brian. Okay, Adam and Bob. He knows who he is. He knows who he is, but they don't know each other. We assume that they know themselves, but not each other. A, B. A knows who B is. But does B know who A is? No. Why? Because B is kind of famous. It's a prom king, okay? Everybody knows who B is. He's a hunk, football star, whatever. But does B know who A is? No. B is a celebrity. Okay? How about D? This? Well, it's just same configuration as this guy, right? Now, we're just switching the name. Yeah, as a celebrity, B is unknown. Yeah, it's same as this. We're just switching the name. It's arbitrary, right? So, we can erase this configuration because it's symmetric. It's same thing. It's arbitrary assignment, okay? Yeah, A knows B and B knows A, okay? They are acquaintances. They know each other. Let's say two celebrities like Mr. Trump, Mr. President Trump, and Mark Zuckerberg. Let's assume they never met each other, but they know each other by reputation because they are both celebrities. Okay? let's say Vladimir Putin and Mr. Uh, Bill Gates. They probably know each other's reputation, but it's possible that they never met and they never talked to each other. They never exchanged correspondence, email. They never talked to each other on the phone. But yeah, they know each other by reputation. Okay? They recognize the name, Mr. Bill Gates, Mr. President Vladimir Putin, or Pope Francis and Bill Gates. Pope Francis and Madonna. Maybe they never met each other, but probably they know each other by reputation because they are both celebrities. Okay. Okay. Oh, how about this? A knows B. Maybe B is Schopenhauer, Immanuel Kant, or Socrates. Socrates, does he know me? No. I wasn't even born when he lived. Jesus, does he know me? Well, that's a religious question, right? Yeah, we Christians, we believe, yeah, Jesus knows everybody. It's like God. Okay? Jesus loves you. He loves me. That's a religious concept. Okay? But Socrates, he's not a religious figure, right? So yeah, he doesn't know me. I wasn't even born when he was living. So, but I know Socrates by reputation. Like what? 2,500 years later, yeah, I know who he is. It's like he lives forever, right? In the people's mind or in books. Metaphysical existence. Okay, his existence outlives his physical existence. Socrates' metaphysical existence, his legacy, his philosophy outlives his physical life. Posthumous fame, okay? Enduring legacy, okay? All right. How about A and B? Yeah, maybe. Let's say A is me, and B is somebody who lives in the outback country or some remote town in Alaska. I don't know him, and he does not know me because neither of us are famous person. We are not celebrities. Okay, probably we'll never meet each other. Okay, but if I become famous, maybe B will know who I am. But probably I will never know who B is if B stay unknown. If B become famous just like I will be, hypothetically, then yeah, later on we will know each other. So now we are doing dynamic graph theory, just like we have set theory and we have dynamic set theory, right? Now we had graph theory and now it's dynamic graph theory because we are adding this time variable. Okay. We didn't know in the past. I didn't know B in the past. But let's say B become some famous local politician next year. Then yeah, I will know who B is. But me, yeah, I didn't get elected. So B does not know me. Okay, so yeah, it changes, this graph changes over time. Okay. All right. So that's A and B. And next step, one more. A, B, and C. Yeah, it previously we tried to cover everything, so it kind of overwhelmed us. But it doesn't have to be that complex, okay? We can just have fun, okay? See? Yeah, let's just keep it simple, okay? Let's not overwhelm ourselves. Let's not try to be perfect, okay? Yeah, let's just have fun, some fun, okay? Be simple. We're gonna take a break, okay? And we get back to this, okay? Okay, we're back. So, um, we're gonna talk about population real quick. Demographics. Okay, just real quick. I mean, how many of us are babies? How many? The baby population, let's say under 2 years old, from 0 to 2. Is it even distribution? You have zero. Let's say people, everybody dies at 100, whatever, right? Is it even distribution, or does it look like this bell curve, or is it even distribution? We'll talk about graph theory later, okay? We have only 30 minutes. Time goes so fast now. Or is it even distribution, or is it kind of look like this, or from 0 to 100? What does it look like? Assuming population stays the same, the number of people in America. Let's just assume number of American people are just what, 300 million maybe. Let's say it stays the same. Then okay, what's the snapshot from 0 to 100? Here you have 50 years old. How much percentage are this? What are the distribution of people in each age level? Okay. Okay, let's assume the population stays the same. Okay. I mean, I can look it up in the internet, but let's just try to guess. Okay, mathematically, right? Okay. Okay. So as time goes by, let's say in this island there are 100 people. Okay. Every year, one person dies and another person gets born. Okay. 100 people. Every year, one person dies and one person gets born. Every year. And there are 100 people every year in this island. If that's the case, then it should be flat. 100 people, okay? The person here, and number of people is 1. One person gets out by dying, gets out of this world, this island world, and one person gets in. And everybody every year move to the next. It's like a line. Q. First come, first out. Okay. Oh, this is funny. Every person, yeah, is one line, single line, 100 people long, this line. You're 100 years old, oh yeah, you get out, you die. Next, some baby comes, okay, 1, 2, 3, 4, 5, okay? Yeah, it's like flat earth kind of model, okay? You can see it that way, okay? So let's say after 1 year, yeah, this baby become a child, infant, and then he start to know who he is. He recognizes his name. He look at the mirror. He knows, this 1-year-old baby knows, yeah, that's me in the mirror. Let's just assume that, okay? Then 99 people know who he is. Or maybe you're 99 years old. You're suffering from delusion because Parkinson's disease or whatnot, so you don't know who you are. Baby, you kind of become like a baby when you're old, right? You're weak, you're dependent, okay? So yeah, just like baby. So 2 people doesn't know who he is, but 98 people who knows who he is, okay? Or maybe there's one person who's delusional, so he doesn't know who he is, so maybe 3 people doesn't know who he is, okay? But 97 people know who he is, okay? So let's focus on the majority case, okay? Or maybe another person suffering from amnesia, okay? Okay, 4 people doesn't know who he is, 96 people know who he is, okay? So let's focus on the majority. Okay. Probably if population stays the same, maybe I'm thinking like graph looks like this because some people have car accident or commit suicide, and so there are less people that reach 100. Okay, I'm thinking some people die from accident, commit suicide, or die from murder, or some die from disease, or whatever, right? Or some natural death. Yeah, I'm thinking it kind of looks like that. Okay. If population is not growing or diminishing, yeah, whatever. Yeah, let's go back to graph theory. Okay. So it'll be more fun now. A, B, and C. Okay. Three people. Okay. We'll make it entertaining. Okay. Let's say they're just unknown people. Okay. And A and B, they know each other. They're friends. Okay. And B and C, they know each other. But A and C, they don't know each other. So B is a mutual friend of A and C. But A and C, they never met. They don't know who they are. Okay. All right. Let's say A never met C. Okay. But A heard about C. Why? Because B is a mutual friend, so B talks about C sometimes. So A knows C by name, but A does not know who C is because A never met C. So A and C are total strangers to each other. They recognize each other's name, but they've never seen the picture, or they actually never met. Okay. All right. That's one scenario. Another scenario. B and C know each other. Okay. By the way, this is equivalent to A, because A, B, and C, they are just arbitrary three people. They are totally equivalent, and they are also equivalent A, B, C. You A. Oh, okay. All these three pictures are equivalent, okay, because ABC is arbitrary names, okay. So in terms of counting, combinatorial counting, yeah, we just count all three as one. This, okay, is representative of all three. All right. So you have two lines, one line, or third case, no line whatsoever. Fourth case. Okay, so we are doing combinatorial counting, okay? There are four cases. No line, no connection, nobody knows each other. Everybody knows each other. Only two people know each other. And yeah, two people know each other, but there's missing link. Okay? Four cases. When we only had two, there are only two people, there are only two cases. Okay? We're not gonna think about this celebrity, this one direction. No, we're not gonna think about that. Okay? At least not now. Okay? We will only think about this line without any arrows. It's implied. It's bidirectional. They know each other. Okay? So when there are two people, only two cases. When there are four people, four cases. Okay? How about there are four people? I don't know. Okay? It's combinatorial problem. I don't want to think about it. Okay. Alright. Here is this. Okay? let's say it's more than just knowing each other. Let's say that this line represents friendship. Now, A is excluded. Okay. I told you we're gonna have some fun with this, alright? Yeah. Humanology. Human phenomena. B and C are friends, but A is a loner. Okay, it's excluded. Maybe B and C they don't like A, or maybe A just want to be by himself. Who knows? Maybe both. Okay, whatever. Now B is a mutual friend. Okay, A, B, and C. Yeah, none of them like each other. A, B, C. Yeah, everyone's getting along. Okay. How about absence of line means hostility, enemies? Okay, let's do that. B is a bridge, mutual friend, but A, C they hate each other. Here, B, C they're good friends, but they hate A. A hate them. Oh, those people. Grouping. A, B, C, yeah, they hate each other. Everybody hates each other. A, B, C, oh, such a peaceful village. They all love each other, okay? All friends, okay? That's it. I don't want to talk about anything anymore. Why don't you think about this, okay? How about 4 people? Let's try 4 people, okay? Ooh. Maybe we should go to like this three-dimensional space, X, Y, Z axis, kind of pyramidal kind of stuff, right? Okay, you have A, B, C. Let's say we are building a pyramid, okay? It's a pyramid. Three-dimensional object. So it's a pyramid, okay? Like a crystal, you know. It's behind this plane, behind this triangle DBC, okay? That's why it's dotted line, okay? Whew. It's one way to look at it, but we're not gonna do that, okay? Because it's too hard to draw. We put A at the very center of the universe, okay? A, B, C, D, okay? We put A at the center, okay? How many cases there are? Well, A no B, A no C, A no D, D no B, D no C, B no C. Everybody knows each other, okay? Yeah, you can think of it as DBC triangle as a plane, and A is kind of on top of them, okay? Apex, the king, prom king, whatever. A is sticking out of this plane, okay? You can see it that way, okay? Can you see all this? Yeah. I drew it pretty big, so. Okay. It's a model of human relationship, okay? Relational graph theory, okay? That's what we're doing. Okay. And maybe one interesting way to think about this model, what would be some practical application with this model? Maybe a family or employer-employee relationship, this hierarchy in a company, okay? Yeah, let's do that. You know, women tend to live longer than men, right? Why? I don't know. Men, we lose hair. Women, they don't lose hair. Typically, men get bald. Women typically they don't get bald, right? So men and women tend to live longer too. So they retain their hair and they tend to live longer than men. Okay, statistically, right? So yeah, in a typical household, you have grandmother, right? You have grandmother. Grandmother have let's say two sons. Okay, one son and one daughter. Okay, and they have spouse, but spouse they're one body, right? Married couple. So they have two children. Okay, your grandchildren, four grandchildren. Okay, child one, child two, child three, child four. Oh man, it's so boring. Oh, family tree. Oh, it's kind of boring. I'm sorry. How about work? Okay. How about in the military? Would it be more interesting? Okay. Let's say you have staff sergeant, okay, and then you have platoon leader, whatever. Okay. You have several sergeants, and then you have privates, right? Specialist, junior enlisted. Oh, it's boring too. How about in a company? You have big boss, middle management, and then just small guys like us. You got the idea. Let's not throw this. It's getting really boring. We wanna do something exciting, entertaining. When we did this influence equation, we had a lot of fun there. Okay, uh, because we were like dealing with the power, celebrity, and stuff. I think it was like yesterday. I watched this old episode of Apprentice TV show. Oh, it's so exciting, right? Because this Mr. Donald J. Trump is rich guy. He has his own helicopter and this fancy Trump Tower board built and boardroom, and it's so exciting. It's very, I love that TV show, Apprentice show, and so yeah, I liked him. I used to like him a lot. President Trump, Mr. Donald J. Trump. Yeah, his TV show, his books, they're fantastic. But he became the president. I voted for him, and now I don't like him very much because he's so happy, Oh, so proud. He hang out with all these politicians who are very proud, very happy. I don't like that scene. I don't like seeing that stuff. I'm happy, I'm powerful, I'm happy, I'm in paradise. Everybody's happy in Washington D.C., the White House. Oh, photo ops, they're all smiling. I'm happy, proud of themselves. They think they are so smart, smiling. Oh, it's so disgusting scene to look at. But in this Apprentice TV show, there are these job applicants, the apprentice wannabe, right? So they're competing with each other, and there's the drama. Oh, it's fun to watch. Season one, Apprentice TV show. Of course, those girls, they're there probably because they are very pretty. I mean, at least a couple of them, right? Not, yeah, but also there are interesting character like Omarosa. Oh, she's very interesting character. And there's this Kwame, whatever, and or this Troy, and many interesting characters. Okay, give me 1 second. How much time do we have? 15 minutes. Yeah, Apprentice TV show season one. I greatly enjoyed that. It was no, just some advertisement email in my cell phone. Yeah, Apprentice TV show. It was fantastic, very interesting. right? Because they're dealing with this fancy stuff like Mr. Trump, like this real estate businessman with a lot of money, somebody important. It's Manhattan, New York City, all this glamour, That's why it was so exciting. Something unusual. Somebody rich, somebody powerful, right? So yeah, all these people, yeah, they apply to this job to be with, to work with somebody very powerful, famous, and rich, Donald J. Trump, right? Yeah, it's a fantastic TV show, and yeah, it's very entertaining and also educational too. I love that show. Okay, I read many of his books. President Trump, I mean, back then, Mr. Trump, right? Yeah, very educational, very exciting. I learned a lot from reading his books. Okay, so that's people want to work for somebody rich, powerful, and famous because what's going on there is this reliance on somebody's power. Okay, I mean, Donald J. Trump himself inherited money, power, and fame from his father, I mean, Trump Sr. I don't know his first name. Okay. Oh, of course, Donald J. Trump, he worked very hard, right? So that he succeeded in his business. He wasn't that successful, actually. But he just got by. It was just surviving business, okay? It was not really thriving business, okay? Yeah, he just managed. He managed to get by, survive. Okay. So, because he isn't that smart a guy actually. Okay, he's not like Bill Gates or Sam Walton. Yeah, they are the one who really, or Mark Zuckerberg or Jeff Bezos. Yeah, those are really smart people, good businessmen. Or Warren Buffett. You know, Trump is not like that. Okay, he just kind of survived. Okay, that's all. Yeah, he isn't that successful a businessman. Interesting character though, right? Yeah, after all, he managed to be elected as the president, and but I don't think he's doing very well in politics. Just like he didn't do very well in his business. Okay, but I think he's a good educator in terms of Apprentice TV show or the books that he wrote. Yeah, he shared his knowledge, some wisdom with other people like me, so that I can read his books, watch his TV shows. Yeah, it's a good educator. Yeah, so sometimes I do regret having voted for him, but sometimes I don't. Okay, because but I don't like the fact that he's also happy taking this picture with people, politicians, and all these meetings. He's not quite making anything done. He's not quite getting things done. Okay, because all he's doing is just happy this party, this retirement, yeah, meeting, right? All these talks. He's not quite getting anything done. I mean, border wall. Okay, I mean, of all people, he should know better. Okay, he should approach it as a business, not as with taxpayers' money, or tariff, whatever. Not very smart. I guess he's getting old. Okay, it's, he doesn't have that entrepreneurial spirit like he once used to have when he was younger. Okay, he's just getting old. Okay, so the problem with this American politics is this: you have to get quite old to establish yourself, your money, power, fame, and then you get into politics, because politics doesn't pay. Okay, unless you are in a national politics. Local politics, it barely pays. Okay, why? It's market, pure economics, right? Demand and supply. Okay, we have this humanological economics equation or economical humanology equation. Price is demand over supply. Then a lot of demand, then price goes up. A lot of supply, price go down. Everybody want to be a politician. Everybody. Actually, price can be negative. Okay, so price is demand minus supply. Price can be negative. If there are a lot of supply, like in Hollywood, so many people want to be an actor. So there's this negative price. People pay. In Hollywood, sometimes people pay to get an audition. Okay? You don't get paid for this acting job, but you actually pay to get this acting job. Sometimes that happens. Okay? For women, they pay with their vaginas. Okay? They sleep with casting director or director, to get this role. Yeah, look at Harvey Weinstein. So many actresses, yeah, they have sex with him to get this acting job. So they pay in order to get acting job, rather than they get paid for this doing acting job. Okay, so negative price, right? Politics, same way. A lot of political positions are voluntary basis. They don't get paid at all. Sometimes that happens. Or they get paid very little. Why? Because everybody want to be a politician. A lot of supply. But you have only so many positions. It's like pyramid, right? On top of this, big time CEO or some political position, high positions, everybody want that. But there are a handful of positions. So that's why local politics, they don't get paid very well. So then who get into local politics? Somebody who already have a lot of money. Okay? Secondary income. Maybe they're retirees, or maybe they're private businessmen. Yeah, there's constant income source, right? Or maybe they inherited a lot of money from their parents. Okay? Then they can get into local politics. Okay? Because you cannot survive with the kind of money that local politicians get paid, the salary. Why? Because everybody want to be a politician, right? So, and there are only small demand of political positions. So yeah, price goes down. Okay? Sometimes it becomes negative. Okay? Yeah. So democracy isn't like silver bullet, okay? It become very plutocracy, elitocracy, ruled by elites, ruled by rich people. Yeah, democracy very quickly degenerates into that. Why? Because hey, would you vote for me? Do you think I will be the president in 2021? Fat chance, right? Why? Because I'm unknown. I don't have any money. So then how can I get myself known? I cannot do advertisement. Yeah, I make this video series, YouTube video series, but nobody's watching it. Because I'm nobody, okay? So people just watching these apprentice TV shows, all these people want to rely on establishment. Somebody who is already rich, powerful, and famous. They want to ride on top of that, take advantage of that. Okay? People typically flock towards rich power and fame. Okay? Not just women, men too. Yeah, women want to marry President Trump or Harvey Weinstein. They want to have sex with him. But men, we want to work for them. We want to work for a very big company, corporation, right? We want to work for president. We want to work for big time CEO like Bill Gates or Mark Zuckerberg or Apple. Oh yeah, those big companies, they get tons of job applicants, right? It's just gravity. Just like ideology, right? Yeah, they are part of ideology, concept. They're not ideologists, but concept. This Apple corporation-ism, Microsoft-ism, okay? Yeah, it's just like concept, right? Yeah, it has huge gravitational pull. because it has a lot of money. Okay, so it attracts a lot of flies. Okay, so what happens when a firefly get into the fire? It burns and die, right? Yeah, so all these people who get a job in the big corporations, yeah, I mean, I guess they're happy. I don't know, but maybe they work what 80 hours a week and kind of burn out, just like fly going to the fire. I don't know. I don't know. I've never worked for those big corporations. Just saying, okay? Just take it as a joke. All right? So, yeah, they rely on the power. People, that's kind of interesting. But it's very entertaining. Why are we talking about this? Because we want to come up with some nice, entertaining graph theory, but so far we failed. I mean, in the influence equation, we had a lot of fun because there was all this algebraic equation, and it kind of start to look like. I mean, we started with this gravitation equation by Newton. So yeah, we are kind of relying on this Newton. Oh, Isaac Newton. Yeah, maybe that's why it was interesting, because we rely on somebody famous, Isaac Newton. Okay. And just like Apprentice TV show is exciting and interesting to watch because there's Donald J. Trump, rich, powerful, and famous guy, right? And influence equation, maybe it was exciting because we had Isaac Newton there, the gravitation, the famous equation of law of gravitation, universal gravitation. But graph theory, oh, come on. Family tree, come on. It's just too common. Maybe that, come on. It's too common. Come on. It's too common. So it's just insipid. It's not very exciting. Oh, tree, yeah, we have trees everywhere. It's too common. We have family everywhere. There are companies, hierarchy everywhere. It's too banal, too commonplace. Maybe that's why it's not so exciting. And who's some famous figure in graph theory? Can you name a name? Yeah, it's not quite interesting. Okay, so it's a passing note. Okay, so now our 3 hours up. Okay, we've done for 3 hours. So, okay, bye. Good night. See you later. Bye.